Hello, this is Dr. Mike. This is for my CIS 2642 classes, and this is a look at Topic 12. And it is, of course, exploring application vulnerabilities. At the time of this recording, it is Chapter 9 of the textbook, the CompTIA Pen Test Plus guide. And we're going to cover some of these topics here. Again, I won't look at the textbook, but we'll probably glance at the summary, make sure we cover most of the stuff here. But this is actually a really good one to look at, this chapter. Just overall because app vulnerabilities exposed via the web is going to be a huge part of your work probably. A lot of web app pen testing, as no surprise, a lot of stuff is being hosted over the web. Even mobile, APIs, calls back to API servers. I mean, it could be considered part of this testing, but for now we'll just stick with the chapter material. So again, we'll look at the chapter material here, and one of the biggest things, of course, is input validation. And what that means is, whether you're coming to a web page or it's being passed straight, hopefully not straight to a database call or vice versa. Your input comes in from the user and is not checked at all, and it dumps straight in either into a web form, let's say, or some part of the web component, or that is passed into a database. And this is usually referred to as an injection. And our OWASP top 10, which has been shuffled around a little bit, things like cross-site scripting and of course injection have been sort of combined into injection here, and that's what we are looking at here. This is 2021. It's down to number 3, like it's a competition, but is injection vulnerability. So overall, again, you may have seen this before. I can't say how much of a great tool this is. The OWASP Top 10 tool literally gives you a framework what to look for. If you're not even sure where to start, you're like, okay, I have a web page. What should I look at? Should I look for broken off controls, cryptographic failures, injection flaws? Again, using some things we looked at before, Nmap scanning, everything from just port scanning, version scanning, to CVE, vulnerability scanning. Again, and then if you're not sure, you think, I think I found maybe an injection flaw. You click on injection here, it's going to talk to you about it, give you some examples, and we'll look at some of these in detail here. But even better is how to prevent. And this is great. This is the kind of stuff that I would copy and paste. Plagiarism. I'll probably put if I ever copy and paste, whenever I copy and paste stuff from OWASP, I always put a link to it, even just a basic link in my client's reports. That way, I'm sort of sharing more information. In fact, if they click on the link and find more information here, that's great. We want to share that, so we're not just trying to, act like we just copy and paste and not keep it a secret. But it's great to share this information with the client, because even if they're the end reader of the report, it's like, well, I'm not really a developer, but there's cheat sheets on here for prevention for our Java developers. So right there, because the kind of stuff you want to share, be the hero as a client, not just the attacker. So. But basically, it's allowing inputs straight in. We're not validating those inputs at all. And the idea is you never want to trust the user. And that sounds funny as the whole customer end thing, but never trust the user input. Input should always be validated, whether it's blacklisted or whitelisted, using some sort of functionality built into the inherent code base to parameterize. Always tongue twister in that one. Scrub it, whatever you want to call it, input check or validate. You want to do this. If it's not done, there's huge issues open up here. And then look at you can send more parameters. This is actually a SQL injection parameter along with it. So it's called parameter pollution. The idea is hopefully it continues on and validates all parameters sent. So we talk about web app firewalls, let's talk about the input validations here. So first off, talk about our tool base we want to use with this. And I'm probably going to go up the slides here a little bit. We have the OWASP top 10, Burp Suite, can't say it for Burp Suite, professional version, or even just the community edition will allow you to go and test and for these type of things. But you can also use Nikto. Nikto is a great scanner. You can point at a website. And there's some plugins you can use, port numbers you can really tune in on. Nikto homepage will give you information and examples and a user guide Again, I'm going to go through all this in a Nicto class per se, but there is ways to use Nicto here to help you save reports and you can also output text in an HTML report, which is nice. It's not a really fancy HTML report based off of coming from Burp. Burp has got fantastic output reports. It still is something. And here's the idea again: it's the two-tool mentality. If Nicto and Burp both find a possible injection on a URL, maybe a parameter URL, parameter pollution, it's a good chance you might want to follow it up manually. And it's so it's a good way to go ahead and maybe find ways to get rid of those false positives. So other things, of course, is we have our WP scan. If they're running a WordPress plugins are known to have issues. WordPress versions. WP scan's a great tool. Fire it up and then update it and post it and run it and post the results against your client. Even if it is false positive, it forces them to go and check their WordPress site for updates, and there's nothing wrong with that. But if you're going a full red team attack, WordPress is a great, and it's usually a huge target because all the plugins a lot of times get out of date and they do have vulnerabilities. So it's WP scan. SQL map. Oh, SQL map's fantastic. So there's an example here. Let me show you an example here. So what I usually use SQL map for, I just don't use it hastily against the site. If Burp, Zap, or Nicto, someone comes back saying there's a possible injection with this URL, I'll look at the results and then take that URL and send to SQL map. And you can see right here, a lot of features you can do with it. You can add some heuristics to it, things like that. But you can read the wiki for breakdown of all the features. There's demos here and so on. But SQLmap.org is a great tool to have. Probably up there with, Nmap being, I think, is a primary tool, and then a Burp or Zap. Burp Pro, if you can get a copy of Burp Pro, that's probably the premier tool for web app pen testing. But SQL Map, Nicto, these other tools are great. So again, this thing will go through and check, and if it's injectable, it actually will kick off an injection, and it'll save that session. You can always go back and re-inject or use that injection again to get further in. And that, again, we get into our, then we got our exploit. What for the recon can I get, and what loot can I get? And this, of course, is the end game. A lot of times, this is really the end game. Can I get and extract out PII? I know it's horrible. Account information from clients. Database tables with client information, or the exploit might give me to stuff on disk. Files, things like that. And it's okay to collect this information. Again, collect it, protect it. If you do get actual client information, but you sort of want that shock and awe to really show how bad some of their stuff can be. So you don't need to do the entire. You don't need to export the entire website. Maybe just grab a few hundred lines of maybe client data or whatever, just to show it works. Show the injection point. Show how you did it, and show information how to prevent it. That's where these OS Top 10 comes in. And you can use this here, these cheat sheets, the prevention cheat sheets. And you sort of round out your entire attack with some recommendations. So SQL Map's fantastic. Burp Suite, again, there's a web app security. If you can create a free account, which I did under my my college account here, and you get free information, free training. Again, so what is SQL injection? It's basically allowing calls directly to the database. So how can you find this? A lot of times Burp will find this for you, and you can test it further. I've had some false positives from Burp recently. Again, look at the results closely, and really want to make sure if that's what it is. I'm not going to go through the video here. There's some examples. And then, of course, the idea is category equals GIFs, right? Anything we see, anytime you say URL or equals, or you see a page with a search feature, try it out and look at the URL. Is that URL, is it getting past that parameter? Now, hopefully in the back end, this parameter is being, input validated. If you talk about here, it's hopefully being validated. And If it's not though, it's possible you could pass in a SQL injection, which basically looks like this is basically a SQL comment. Something you can try too, though, as I mentioned before, is error pages. Put in some really bad categories. Put in some goofy category name, and if it comes back with a like a custom error page saying, "Oh, we're sorry that we ran into a problem. Please contact our help desk." That's actually a good result. Get a screenshot of it, show what you did, and give them praise. Say, I had tried this, and you have a sort of custom error page that doesn't tell me nothing. However, put in some garble here, maybe fuzz test this parameter. Put in a bunch of just characters. And if you get an error page from the database, that is something you want to tell the client. Even if you don't get an actual injection, the error page is telling me what version of what, it might actually have information about the database being used. And you want to go ahead and have a guidance saying you need to have custom error pages, do not use error pages from the app. So, this little tip there. But then if you tell me what it is, if I know what database is, I've already have now unlocked the secret. I can actually tune my SQL injection for that database. So, but again, you can see here, you can pass these things in. This is basically telling us it's given a positive result. So it's either 1 equals 1, which it is. So, and since it is, we're going to, again, subvert the logic, and then start giving a user. You can actually start passing in SQL injections in. Now, there's different types. I'm not going to go through all these. There's blind. Blind is a little tougher to use. This is where the SQL map is fantastic, coupled with blind injections. But you're passing in stuff, and you're getting back either a positive or negative result based on the response. And it can be very, very tedious. You literally are going to walk through the database almost character by character sometimes, but until you can figure out what tables are available, how you can interact with them. So there's blind timing based, blind based, and it still goes with this in here. I don't want to go over textbook directly with you, but there's some examples in the textbook. But I guess I end up getting there's some great examples here. Examples here in OWASP. Other injections. Cross-site scripting, which is probably, I'm probably going to jump around here on the slides. But this is really the same thing. Just think of it this way. Again, if SQL injections go against a database, right? So we have a web server here. The calls come into a web page. It's my best draw web page, and they're not validated. And that search criteria goes directly into a database call. That unvalidated search right there is a SQL injection. But if we remove the database component, let's leave it in place here and just remove that. Maybe the web page has some web components, like a comment box, which actually usually is written to a database. But let's say I can write in, and a lot of times this is based off of the script command. So you got to go and do a little basic HTML. ... We can do kick off and then close it. CRIPT. So a lot of times we test for this. We do the alert box with like a hello world or whatever we want, and we'll see that there. And there's just some examples here. We're passing in. Here's you see script source, and of course a lot of times when we do our tests, we do very benign testing. So alert box. And then show the screenshot, show the URL, so you're able to inject a cross-site script inside there. There's persistent, there's reflective. Persistent is if I'm able to maybe actually, let's say, add a comment to a box. So it actually is stored on the website, and it could be, usually it's a database. I mean, it's a huge, great chance. And we're not actually doing a database injection here, but we're storing scriptable content. And then when we go back to the page, any user goes to this page. So here's our non-attacker user. That's my face there. They go to the page, and it actually executes the cross-site script. Now, if it's a box that says you need to give me your username and password again, then I put that in, and then that can be redirected to, our evil server. So it could be it could be a session. You can open up a netcat and listener. I'll do a demo for this probably where we do this. Maybe I grab a cookie or a session ID. Maybe it's nothing you actually see, but it's just something that when the user does log in, I get a copy of it, and that can be like cookies, for example, parameter, session ID, things like that. So there's ways to get that information, and then they have no clue that this is happening, and this is that's called persistent. Reflective is when you leverage the fact, and reflective can be used a lot. I should have kept our person there. We might need them. Again, is our happy end user here. Reflective is when I can attach this to part of the URL. So it's not saved anywhere in the database. It's not saved anywhere here. But I can, let's say, post a link to a website and add the script content here. I mean, it has an alert box now, or it runs a script from another site. That's the word cross-site scripting. It means I can run scripts from other sites. And then when the user, maybe this is sent to them, somehow sent to them, maybe it's posted somewhere else. They see the URL and they trust it. So there's a level of trust there. And of course they click on it, and that of course that executes that script. And it could be a callback to our evil domain. I should have kept that there too. Or it could be, it could be a parameter popped up. Please enter these certain things. It could be a beef injection call, which of course would be back to a domain there. Again, the idea is we're allowing scripts to run from not our site. So I'll probably over-explain that. That's what injection sort of comes in here. And it is an injection vulnerability. It used to be separate in the top 10. It used to be cross-site scripting was separate. But you can see here we actually do the message. Here we have user. There's a badge script.js. That's the thing. They will run JavaScript from another site. It could be get sensitive data, get passwords. Again, reflective might be here. It's reflected back in the URL, and then they're stored or persistent, and that is where we actually store that on the database. And there's other ones too. There's DOM-based, where it's part of the elements themselves. So I've done tests before when I was a full-time pen tester, and here's something you might run into. When you test for this, you might just get a pop-up box, and the developer goes, "What's the big deal? A pop-up box is there's nothing. There's no issue with that." You go, "Yeah, but I'm testing with a alert box. That could be a JavaScript call from somewhere else." And then I've been told, "Well, yeah, but still, it's reflective. If that's back to the client, and it's not our problem. We're not hosting anything vulnerable here." Yeah, the thing though is we're allowing the cross-site script to run anyways, and that's leveraging our trust from our company or your company, and you're going to be tied to the fact that some user went to your website and they were hacked, even though it wasn't really your fault, but it actually was. You're allowing it. And there's ways to sort of really shore up cross-site scripting. And there's some prevention sheets here. Yeah, there you go. Cross-site syntax. So again, I'm looking into the OWASP there, but OWASP, there's ways to prevent that. Again, there's the great stuff here about in the Burp Suite, the Portswigger Web Security Academy helps with that. So next on is command injection call. Again, very similar. It is an injection, but we're actually injecting code to be run on the server. So I'm able to upload and run. In this case, they're actually curl uploading a backdoor.sh and executing it. It could be partial system control. It could be, basically we're actually attacking the operating system. So, and that's really what it is there. So here's an idea. Can we upload and run some sort of script? And will it do it for us? A little hard to get this one. A good up-to-date operating system with some good removal of the OS from the web app level. But again, I never assume that that's good. No one's going to allow me to run anything. You never know. Blind OS injection, things like that. So Anyways, there's a lot of examples here. I don't know which one to show you. There are some ways injecting OS in. And lots of times you can try this from the URL. That's really what it comes down to. Or is it possible to upload something to the end site, to the website, to have it execute? So I think I talked about this before. Password vulnerabilities. This is a huge one. This crosses all aspects of not just web app. We looked at the previous. I think I talked about bad passwords, default credentials. Here's some stuff here that I will say is one to look at, and that is broken access control. Let's see, it's underneath here. What did they move it to? So what we're looking for is the forgotten password site. Yeah, they moved it around. So search for the OWASP forgotten password. Whenever I get an engagement, I always look for forgotten password button. Click on it and see what I'm offered. Sometimes you'll put in, it'll say, please give us your email address, so we can send you a link. If it's done well, send you a link, a ticketed URL with maybe a 24-hour, 12-hour special URL that will allow access of that user account in to a special page, and it goes to hopefully an email that's on file. But here's the thing though, that page itself, let's say I put in, mike@test.com, hit go, and it says, I'm sorry, that email address is not in our, that's not a proper email address, or we don't recognize the email address. That password reset page just basically told me that email is no good. Now I can get a list of possible emails and run that through it, and when I get positive responses back, I now have built a username the dictionary I can use in further attacks. Also, you can go on, if you have a one that says, what's your possible password username. If it tells you either one is incorrect, that username is incorrect, or that password is incorrect at the login page, that's a great one right too. So, again, let's say I try username admin. I put test123 for the password. I'm sorry, that password is incorrect. Cool. I put in the administrator, and I put in password123. And it says, I'm sorry, that username is incorrect. You can see what I'm saying is we have some really ways we can sort of leverage their own system against them to determine username and passwords. So you can automate this. You can use it manually. Password dumps, of course, the rocky.txt, LinkedIn dumps. There's ways to get these. I showed this before. Default credentials, that's a huge one. Definitely search for that. You find a login PHP page somewhere that's maybe for a certain type of infrastructure tool, like maybe a blog, WordPress, things like that. WordPress is pretty good about when you set those up. You got to make a username and a password that's one-time use only type of stuff. But you never know. Look for default credentials. So definitely passwords always there. Again, can we get cookies? So session authentication. If someone does log in, can we guess their cookie? So what we're going to do is we're going to go ahead and log in. There's tools and Burp for this where you basically, it'll check that session ID and it will look for any non-randomness. So date timestamp, is it like date timestamp and then maybe a number ticketed, 1, 2, 3, 4, 5, and so on. You definitely want randomness in your session. So you check your cookies. Always look at your cookies. Cookies might be encoded in base 64. A key is you see you'll see an equals at the end of it sometimes. That's actually a space filler for base 64. Yeah, decode it. See what it looks like. And then if you want, you can literally re-encode the cookie or something else and then re-inject it. So that's what session hijacking, of course, maybe can I guess your cookie? Can I use this? Can I become that person? It could be as simple as user ID in the URL. I log in with a proper user ID, name, password, so I do have a connection. I have a authenticated connection, but it says user ID is 1001. What if I change it to 1002 or 900? Do I get that user's information? So, and can I use some more of the way cross-site script to get and hijack their session cookie? So, uninvalid redirects. Again, simple enough for passing in information. almost like a cross-site script. Insecure reference. What I see here, document ID equals this here. What if I change this to different numbers? What do I get? So that's simple as direct reference options. Vector transversal, definitely a big one here. Simple as just the // right? If I know what type of OS they're running, even if they're running Windows, you might still use the same syntax because the ISS, the Windows web server, should use the same format. But yeah, image source. Can I use this information here? Look at our images. And what if you just take off the image name? Can I view the web page? That's insecure. Most times, if you do this, if I was to go to this URL on there, let's say if I go to their URL, file name or let's try it here. Let's just try it on OWASP. So this picture right here. I'll link a new tab. Okay, perfect. Good job. So OWASP bouncing me back to the home page. But let's go ahead and I did sticker heist. Right click here and open in new tab. All right, so we have H3 Google user content. Okay, so what happens if I take off this? If I change this to something else? Of course, this is what you want. You want a 403. You want some sort of error. Some sites you click on it, and unless they'll say images / image.jpg. Once you take out the image.jpg, do you see a list of directories? That's definitely what you don't want. And then what you're doing is you're trying to just drill your way down. It's either tricking the web page to show you a disk access or using the dots and to see can you get down to the OS level. Also, if I can expose other parts of the website, maybe they shouldn't be exposed. Look at all the files that are available. Never know what you might find. So, file inclusion. This is basically the same as an injection. We're trying to include or upload and run an exe file, for example. Talked about cross-site scripting already. Request forgery. That's when the user's trust on their website to attempt to execute to a third-party site. It's a tough one. For example, if I know my user is while they're logged into their main, maybe this website, they always have their WordPress thing open. Maybe they're constantly working with WordPress. I can set up a series of execution commands to the browser that actually go to the WordPress site. So again, imagine I have WordPress open in this tab up here, and then here I'm logged in, and I click on a link, and it's just going to check, and it's to say, if you have this site open and you're logged in, I'm going to tell it to send some stuff and do it on your trusted login. It's a tough one to kick off. There are ways to do authentication tokens on the site that if the request comes in, doesn't have that token, it just usually does not allow it. So, and this is that Burp will check for. It's hard to check for manually, but Burp will check and try to attempt to run tests for this. I think Zap will do it too. So directory transversal. Last thing, of course, is actual code testing. We talked about error handling already. Look at comments. Look at source. Look at the page source. Look at any APIs that are exposed. So, and look for just bad coding practices. Look at comments. Look at code comments on web pages. Look at any code comments you can find. And then the last part of this is really not probably most for pen testing, but it is a testing tool, and it is possible in an engagement you might be asked to, can you test our source code? This, of course, would be a white box test where you have full access to everything. This is hit and miss. There's some tools that are very expensive. There are some free tools. Two types of tests. So what we're doing is we're taking the code base and we're feeding it into a system, and it's going to search for known bad coding. And looking at two things here. It's static application security testing and dynamic. Again, this is white box versus black box. But in a way, static or SAST means you need to have the source code. You upload some like check marks, or there's a bunch of, there's actually some very expensive tools, and it'll check the code for possible, bad code that allows cross-site scripting or injections. Now, there's a problem with this. SAST can be very false positive intensive. And if you rely upon the developer to go back and check that, it's just going to be, it might be like there's 300 findings. It's going to be too much. It's going to be a tough one. DAST is dynamic and it needs to have, DAST is going to add little apps in the environment and it's going to run these tests for you. Burp has some sort of DAST type features for dynamic. So Burp and Zap has some, and some fuzzers. Fuzzers where you try to just put in different things. So, example, first name, last name. What if I put in a 5,000 character last name? What happens? Things like that. It's more dynamic. It is less prone to false positives, but it takes a little more to set up and run. But just understand what these two are: SAST versus DAST. One's more black box based, but again, there's going to be for a lot of DAST. There's some level of the client interaction. You might install or run certain things, certain runtime apps for some real big commercial ones. But some tools will do this for you, and that would be considered dynamic. So keep those in mind there. That's really it. So yeah, it's a big topic. We're in 30 minutes already. But I can't say enough here. You can see here, understanding ejections, bad passwords, how sessions are handled. Understand cross-site scripting, that is still a big one. And then understand what DAST versus SAST is when it comes to apps and security code. It's okay if you're asked, hey, can you check our code? You might need to come say, I'm not an expert at any kind of, I don't have any tools for it. You might need to actually remove that from your engagement or make it a separate engagement, because there could be certain tools you might need for that, especially for static code analysis. That's really is a larger chunk of work than just a pen test sometimes. So good stuff here in the summary, and that wraps it up for the chapter on exploiting application vulnerabilities. Thank you.